For most samples of DNA, the visualization of the sample using agarose gel electrophoresis can yield important information about the quantity, size, and quality of purified samples. To start the process, an agarose gel must be made by weighing out the powdered agarose and appropriate volume of buffer. It is common for the buffer to be made as a concentrated stock solution that will be diluted as needed, as shown here. This buffer will be used to make up the gel and surround the gel later on to allow the electrical current to move the sample through the gel. When you are ready to make the gel, both the agarose and buffer are mixed into a flask that is heated to boiling to allow the agar to become molten. Be sure to watch the solution, as too much boiling can cause it to spill out of the flask. When taking the sample out, gently swirl it around and look for small beads of undissolved agarose. If a few are present, they may be melted away with swirling, but if there are many, the flask should be boiled a while longer. The molten agarose must be cooled somewhat before it can be poured, or else it may warp the plastic of the electrophoresis unit. This can be accomplished by simply waiting, or speeding up the process by swirling the flask under running water. If you are not ready to pour the sample, the agarose can be kept in a molten state by placing it into a 55°C water bath. In order to see DNA in a gel, it must be stained. Commonly, this is done with a carcinogenic chemical called lithium bromide. To make a stain-containing gel, the lithium bromide must be added while the agarose is still molten. The sample is once again swirled to get consistent distribution of the stain in the gel solution. The electrophoresis unit shown here is also used for casting the gel by rotating the gel tray 90 degrees. This will place the open ends of the tray against the sides of the electrophoresis chamber, making a sealed casting tray. The agarose is carefully poured into the tray, and it is checked to make sure it is going to set on a level surface and without any bubbles that could affect sample migration. If there are any bubbles, they may be broken or removed by the comb or a plastic pipette tip. When placing or replacing the comb, make sure no bubbles are trapped between the teeth, as these can make oddly shaped wells. Once the gel has become more opaque and is fully set, it can be rotated back into the running position. Make sure that the comb is located on the side of the tank with the black or negative electrode to make sure the gel will run in the right direction. Buffer can now be poured into the ends of the electrophoresis unit and to a level just over the top of the gel. The more buffer that is poured over the gel, the less quickly the gel will run. The comb should now be carefully removed so that the gel can be loaded. To get the DNA samples ready, they must have loading dye added to them. This will supply a tracking dye or combination of dyes, such as orange G, bromophenol blue, or xylene cyanol. Additionally, the loading dye will increase the sample density using glycerol so that it will sink into the wells. The dye can be mixed with the samples by gently pipetting up and down a few times. Now that all the samples are ready to be loaded, they will be carefully pipetted into the wells of the gel. As a shaky hand can result in the wells becoming torn or stabbed, it may be useful to rest your elbow on the bench or anchor the pipette against your opposite hand. Ensure you do not dispense the sample down to the second stop, as this will force an air bubble into the well, which can disperse the sample as it floats to the top of the well. A few other things to watch for when loading the gel are air bubbles in the pipette tip, dispensing the sample properly, but then releasing the pipette plunger and sucking the sample back up, or starting to dispense the sample before the tip is safely in the well. Once all samples are loaded, the lid is attached and the electrodes are connected properly to the power supply. The voltage and time may now be set to initiate the process of electrophoresis. To make sure that everything is connected properly, look for bubbles forming on the electrode wires. Also, you may wish to watch long enough to ensure the sample is running in the right direction. You will notice in this time-lapse clip there are two different blue bands migrating, as two different loading dies were used in these samples. After the gel has run for an appropriate length of time, the power is turned off. The lid is removed, and the gel can be carried to a documentation station. This gel is placed on an ultraviolet transilluminator contained within this gel documentation system. Using the size standards provided by the ladder, the band migration distances can now be measured to allow each fragment to have its size determined.